In this video, we're going to look at solving simultaneous equations when we have to scale both equations. So we're still going to use the elimination method to solve our equations. So remember, the coefficients of one of our variables has to be the same. And in these examples, both of our equations are going to require scaling before we can eliminate one of the variables and solve. If we end up with different signs of that variable, we're going to add one equation to the other. But if we end up with the same signs of that variable, we're going to subtract one equation from the other. So our first example, we're going to solve 2x plus 3y equals 1 and 3x minus 5y equals 11 to find the values of x and y to give us our unique solution. The first thing we're going to do is label the equations as equation 1 and equation 2. Now we need to make the coefficients of our y terms or our x terms the same. So I'm going to make sure that our y coefficients are the same. So we're going to multiply equation 1 by 5. And that's going to give us 10x plus 15y equals 5. And we're going to label that number 3. And then we're going to multiply equation 2 by 3 to make the coefficients of y the same. And 2 times 3 is going to give us 9x minus 15y equals 33. And we're going to label that equation 4. There are different signs for our coefficients of y. We've got a positive 15y in 3 and a negative 15y in 4. So we're going to add 3 and 4 together to eliminate y and solve for x. And that gives us 19x equals 38. We're going to isolate x by dividing both sides by 19. And that gives us a value of x equals 2. So the next step is to substitute this value of x back into equation 1 and solve for y. So we get 2 times 2 is 4, plus 3y equals 1. Then we're going to take away 4 from both sides, and that's going to give us 3y equals negative 3. And then we're going to divide both sides by 3 to get y equals negative 1. Then remember, we want to mentally check our solutions by substituting both values back into both equations. So 4 plus negative 3 is going to give us 1. And 6 take away negative 5 is going to give us 11. So we know that our solution works in both of our equations. So our final answer is x equals 2 and y equals negative 1. So our final example is to solve 4x plus 3y equals negative 1 and 7x plus 2y equals negative 5. So the first thing we're going to do is we're going to label our equations. Now, in order to eliminate one of those variables, we need to make sure that the coefficients are the same. And you can see that the x coefficients are different in both equations and the y coefficients are different in both equations. So what we're going to need to do is we're going to need to scale both the equations and make equivalent equations that we can then use to eliminate either the x or the y term. So what we're going to do is we're going to multiply 1 by 2. So that's the coefficient of the y term in the second equation. And we're going to multiply equation 2 by 3, which is the coefficient of the y term in the first equation. And we're going to write down these new equations. So equation 1 times 2 is 8x plus 6y equals negative 2, and we're going to label that 3. And equation 2 times 3 is 21x plus 6y equals negative 15, and that's equation 4. Now you can see that our y terms have the same signs. So we're going to subtract, and we're going to subtract 3 from 4 to eliminate y and solve for x. So 4 take away 3 equals 13x, and that equals negative 13. And then when we divide both sides by 13, we get x equals negative 1. Now we need to substitute that value back into 1 and solve for y. So we're going to get negative 4 plus 3y equals -1. We're going to add 4 to both sides and get 3y equals 3. And then we're going to divide both sides by 3 and get y equals 1. Now remember, we want to mentally check our solutions by substituting both values back into both of the first two equations. And we can check that -4 plus 3 equaled -1 and -7 plus 2 equaled -5. So both of our equations are true. So our solution is x equals -1 and y equals 1.